The day is the 16th of July, 2026. A day that will go down in Maths Olympiad and IMO history. This morning, I went onto the Art of Problem Solving website to find the day 2 problems, and I could not believe what I was seeing. For those of you who might not follow Olympiad maths that much, something that has been happening recently is that various Olympiads have been getting stacked with as much combi as is allowed. Even in this year's IMO, problem 1, which takes up the number theory slot on the paper, as I said while solving it, some aspects are just combi. Last year's IMO problem 5, taking up the algebra slot, again, some aspects are just combi. In 2020 IMO problem 6, not that I solved it, I saw something I never thought was possible. A problem taking up the geometry slot on the paper, but that's actually combi.
That's football heritage.
But today is different. For the first time ever, today we're going to be solving IMO 2026 problem number 4. My new all-time favorite combi problem. A problem, the likes of which I never thought I'd get to see in my lifetime. A problem which takes up the combi slot on the paper, but that in practice is actually geometry. Hello everyone, welcome back for day 2. And I've just got to say, looking at this day 2 paper, I'm overjoyed because I said that day 2 we're going to have combinatorics and algebra at the problem 4 and 5 positions, which is not my strong suit. Then I open the paper, and I see combi geo as the combinatorics problem. So combi geo is basically a mix of combinatorics and geometry. And personally, I find that these type of problems, like reading the problem, it looks like it's more about your understanding of geometry rather than your understanding of combinatorics, right? Like I think there was a period of time when a lot of these sort of questions used to come in BMO1. I remember like something with a frog, or a circle or something. Like questions like this, they're technically combinatorics, but it's actually geometry. So it's nice to see a problem like this after having seen so many problems that I don't know are technically number theory or technically algebra, but which is actually combinatorics. For example, like last year's problem 5 on the IMO. It's technically algebra, but when you're solving it, it feels like you're doing a combi question. This one, it's combi, but it's actually geometry, and I just love to see that. And problem 5, I said it's a function. It's a question of functions, which happens to be my one of my stronger areas. Like it used to be. I think there was a period of time it was actually my best area, but like I haven't been doing much practice of it recently. So again, I'm not 100% sure that we're gonna solve question 5, but let's hope it doesn't end up like question 2 then. Like even if we solve it, I hope it doesn't go that badly. So yeah, let's start with obviously question 6. Question 6 is gonna be hard. Like yeah, question 6 is gonna be hard. Number theory, it's gonna be hard. Um, the smallest positive integer, so that the GCD of oh, it's another question about GCDs. Okay. Um, bigger than 1 for every I. Okay. Huh, okay. So it's like, okay, okay. Yeah, let's start with problem 4. So, so two people are playing a game. There's an angle that's known to both players. Initially, the first player makes a triangle with measurements of their choice. Okay. So if the triangle has an angle equal to theta, the game stops and the second player wins. Okay, so not the one who chose the triangle, the second player wins. Otherwise, the second player chooses a point on the perimeter of the triangle and then draws the line from the vertex to the point, splitting the triangle into two triangles. And then the first player picks one of the two to become the new main triangle. Okay. So for which values of theta can the second player guarantee that after a finite number of steps, one of the angles of the triangle is going to be theta? Okay. Yeah, again, like we did with problem 1, let's just try some examples. So okay, so theta is between 0 and 180. Okay, but what if theta is 90? If theta is 90, then the first player wants to stop the triangle from having a right angle. Okay, but like with this, the second player obviously wins, right? Because whatever triangle, whatever triangle the first player puts, second player just puts the foot of the altitude, and then whichever triangle you pick is going to have a right angle in it. Okay, so theta equals 90 is um a winning angle. Let's call them that. Let's say the winning angles are the ones where the second player can win, and losing angles are the angles where the second player can't win. Yeah, let's do it like that. Okay. So theta equals 90 is winning. What are other like nice number? Okay, let's say theta is 60. That's a nice number. So you have some like random triangle that doesn't have an angle of 60. Okay. Okay. This is so so what at least one of the angles is going to be bigger than 60. So let's say this one is bigger than 60. If I split this, if I draw 60, if I draw a line so that this angle is 60, then the first player is forced to pick this triangle. It's like I don't know, in these like game questions, it's like you often want to if you're trying to win, you often want to pick moves that leave the other player with relatively few options. Because then you have control of what the other player does, and you can devise your strategy in a better way if you know what the other player is gonna. So you do a move, you give the other player a game state, and if you know what you're getting back, you can plan your strategy better. So like forced moves is always a good thing. So with 60, if one of the angles is bigger than 60, I draw this line, and they're forced to pick this triangle. Okay, so I can keep forcing the first player to pick a triangle. but there's no guarantee that that triangle is ever gonna have an angle of 60. Like I forced the first player to pick this triangle. And then I have this triangle. And then I can do the same trick again, put like 60 degrees here. And then they're forced to pick this triangle. And then like that's kind of the same as the first one. So like I don't think there's with this strategy at least, there's no guarantee you're ever gonna get 60 degrees in your main triangle. So maybe theta equals 60 is gonna be losing. Okay. I mean, this strategy definitely isn't gonna work for angles larger than for angles larger than 90. Definitely for angles larger than 90. Because for angles larger than 90, okay, for an angle larger than 90, if they give you an acute angle triangle, the only way, like, let's say theta is 120. If theta is 120 and they give you an acute angle triangle, the only way you're going to get 120 is by doing something like this and getting 120 here. Okay. Yeah, so surely if theta is bigger than 90, if theta is bigger than 90, that's got to be losing, right? Because if theta is bigger than 90, the first player just gives you an acute angle triangle, and then whatever point you pick, here, one of the triangles is going to be acute. So the first player can keep picking acute angle triangles. And so if theta is bigger than 90, there's no way you can win. Okay. Yeah, if theta is bigger than 90, I think it's 100% you losing. Because you can keep picking acute angle triangles, and there's no way that a Mulan can draw the line so both of the triangles are obtuse. Have so that both of the triangles so both of the triangles have one obtuse angle. There's no way you can divide it. There's no way you can draw a line to divide an acute angle triangle into two triangles, both of which have an obtuse angle. Yeah, okay, so theta bigger than 90 is definitely losing. So we're just gonna look at theta less than 90. Maybe it's just theta equals 90. Um, okay, I don't think we tried hard enough for theta equals 60. Like, yeah. I mean, like theta equals 90, making an angle of 90 here was useful. And our argument for theta bigger than 90 is with this thing as well. So maybe doing something like this is a good idea. Oh, actually, yeah, this is a very good idea because you can draw an angle. Okay, so regardless, whatever triangle they give you, like whatever, let's say this is like ABC, you can pick a point P so that APB is equal to 60. And then if they pick this triangle, they lose. So they have to pick the triangle with 120. But then this is good, right? Because then you can just draw the angle back. You can just split it into two triangles which both have a 60-degree angle, and then you win. Okay, so 60 is actually winning. Nice. Okay. Um, Surely, um, okay, let's try theta is 30. Theta is 30. Let's say you draw the line. Um, let's say for theta is 30, you draw a line that makes. But what if you're not able to do that? Wait, hold on. You can get a triangle with angle 60. You can get a triangle with angle 60. So they give me some random triangle. I know it can get that down to a triangle which has an angle of 60. And I want to have a triangle with angle of 60. I just draw the angle bisector, which gives me two triangles with angle 30, and you have to pick one of them. So 30 is going to be winning as well. So every factor of 60 is going to be winning. Wait. Um, no. 60 over 2 to the k is going to be winning for all k. Yeah, so 60 is winning, 30 is winning, 15 is winning, and from 1990 is winning, 45 is winning. Okay. Okay. So these are like your nice angles, right? Yeah. But what about like 75? Does 75 work? Because 75 is like another kind of like a nice angle. So if these ones are working, 75 probably works as well. Um, okay. Wait, what's 180 minus 75? 105. Okay, so 105. Okay, I think in this problem, constructing constructing the examples is going to be quite easy. Right? Constructing the sequence of moves that makes Mulan win, that's going to be quite easy. Like, yeah. Well, proving that an angle doesn't work, I think that's going to be harder, right? Yeah. That's definitely going to be harder. Okay. So, for 75, why is that? I mean, okay. What if 75 doesn't work? Oh, okay. Okay, so, okay. Yeah. That's right. Problem 5 looks exactly like QM, AM, GM. So yeah, just a random observation. QM, AM, GM. Yeah. Well, okay. So for 75, can Mulan win? Okay, so you get a triangle, and then what if all the angles are less than 75? Is that possible? Yeah, of course, like an equilateral triangle. Okay, let's say the first plate gives you an equilateral triangle. Then oh wait. Wait, I feel like I'm having a very good idea. Yeah, okay, wait. What if okay, if you have an angle theta that can be written in the form Because obviously when you have when we do this thing, then you get theta and 180 minus theta. Um, yeah, okay, I think this is good. So if these are both um wait, okay, I'm thinking what if you can write what if there's an integer k so that k theta is 180? Then both of these angles are gonna be 180 minus theta equals k minus 1 theta. Okay, yeah. So both of the angles are going to be multiples of theta. And okay, if you have a multiple of theta at the top, then you can just draw. So if this is like k theta for like an integer, then you can draw theta here, and they can't pick this one, so they got to pick this one. And then they pick this one, and then you draw theta here. Then they got to pick this one, and you keep going. And then eventually, you're gonna get down to 2 theta, and then you win. Okay, so all okay, yeah, wait, that's good, that's good. Okay. So it's theta, if theta is 180 over some integer, then you win. Because this strategy because of this strategy. So if theta is 180, if theta is a factor of 180, if theta is a factor of 180, then you can ensure that the top angle is a multiple of theta after your first move. And then once you have an angle of theta, once you have a multiple of theta at the top, you can keep decreasing the 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 thing the you can keep decreasing the top angle over theta until the top angle over theta becomes 1, and then you win. Okay, yeah, that's good. And 75 is not a factor of 180. Okay, so maybe 75 doesn't work. I think this is good progress for a combi problem. Yeah, I feel quite proud of myself. Yeah, that's got to be at least 2 marks out of 7. Yeah, that's surely 2 marks. That's got to be 2 marks. Okay, because like yeah. Okay, so yeah, now this is the harder part of the problem. So we need to show that no other angles are gonna work. Okay, so yeah. Okay, so we know if the angle is bigger than 90 doesn't work. Why? Why didn't those work? Because the first player can just keep giving you acute angle triangles. Or can both keep picking acute angle triangles? Not yeah. Okay. Um. Okay. Because I'm not too sure what to do now. Yeah. Um. So I need to show. Okay. So for obviously for acute angles theta, there are some triangles for which you can fall. For example, for like 75. If the first player were to give me a triangle with angle 150 at the top, I can obviously just win because I just draw this line that forces the other player to pick a triangle with angle 75. And moreover, wait. If the angle at the top is a multiple of theta, then we know we can win. So that's what we found. That was our strategy for winning. Um, yeah. So maybe wait, is this like a this could are there any other we can like okay, given an angle theta, we can categorize triangles into winning triangles and losing triangles, right? And the way we defined winning angles at the start is that a winning angle is an angle so that every triangle is winning for that angle. So with this thing, we want to show that not all triangles are winning. Okay, wait. What? Okay, so the reason those were winning, the reason those angles were winning, is because from any triangle we could move to a triangle where the top angle is a multiple of theta. So maybe for other triangles, maybe for other angles. Okay, wait. Let's consider the move. Okay, let's suppose that an angle is winning, and let's consider the move before you win. The move before you win, you have to have created two triangles where both triangles have an angle of theta, right? And the only way you're going to do that is either by having an angle of 2 theta at the top and drawing something like this, or by having some like random angle here, some like a random angle there, and an angle of theta as one of your angles, as one of the angles of the triangle. So then okay, in this one you've won already. So this can't be the one before winning because in this one you've already won because you have an angle of theta. So okay, so the move before winning, we need to have two triangles, and both of the triangles are angle theta. These need to be stuck together in some form. And the only way you can stick two triangles like this together are the two here. You can't stick them together. Because if you stick them together any other way, you're gonna get a quadrilateral. Yeah, you're. I mean, yeah, you can't stick two triangles, both of which have an angle theta. You can't stick them together to form another triangle unless apart from these two triangles. Because given any other triangle, if you drew a line, yeah, just looking at which angles. Because if both these triangles have an angle theta, either you can have both theta at the top, or one theta here and one theta here. Or, I mean, theta is a 90, so you can't have both thetas here. But you could have, yeah, what if you have theta here and theta here? That's impossible because this angle is this angle plus this angle. Because that's how angles in a triangle look. So these two angles can't be equal. If you had this angle equals this angle, then yeah, that's the one we yeah. So supposing that none of the three angles of the triangle are theta, the only way you can have yeah, so the triangle before you win has to have an angle of 2 theta. Yeah, that's the only triangle you can win from. Okay, so now Okay, so we know the triangles with an angle of 2 theta at the top are winning. How can you get so theta is winning if and only if 2 theta is winning, right? Yeah, theta is winning if and only if 2 theta is winning. Wait, is theta necessarily an integer? No. Yeah, theta, no, no, that can't be if and only if, because like 60 is winning, but 120 isn't winning. Wait, um, oh yeah, yeah, that's not true because, yeah, that claim isn't true. Yeah, yeah, that's not true. But it is true that the triangle before you win has to have an angle of 2 theta at the top. And so now the other player knows they can't give you a triangle with angle theta or with angle 2 theta. And wait, moreover, they know they can't give you a triangle with angle theta or any multiple of theta because yeah, they can't give you a triangle with any multiple of theta or not multiple is not integer, but like, they can't give you a triangle where you have k times theta where k is an integer. If you have a triangle like that, you know they know that you can win. So maybe, yeah, okay, so if the first player can ensure that they always pick a triangle with no multiple of theta, then they win. Yeah, because if the first player can always pick a triangle with no multiple of theta, then they win, right? Because if they can keep picking triangles with no multiple of theta, then they can keep picking triangles with no angle of theta, and so they win. And um, okay, so if you have a triangle with no, let's say obviously you start with a triangle where none of the angles are multiples of theta. We're gonna call them multiples of theta, even though they're not multiples of theta, because theta is an integer. We're just gonna call them multiples of theta. So let's say you start with a triangle where none of the angles are multiples of theta. Okay. And then, okay, so now we're showing that and we want a strategy for the other player. So now we need to look at how the other player is going to respond given an arbitrary move from the second player. So rather than constructing lines now, we're saying, given any line, which triangle do we pick? And given any line, okay, can both of these triangles have an angle which is a multiple of theta? Well, I know this angle isn't a multiple of theta. I know this one isn't a multiple of theta. I know both of these can't be multiples of theta because theta isn't a factor of 180. So if one of these were multiple, actually neither of these can be multiples of theta because, actually no, yeah, no, obviously one of them can be multiple of theta, yeah. Because at most one of these two are multiple of theta. So the only way is if this one is a multiple of theta, and this one is a multiple of theta. That's the only way. But if this one's a multiple of theta, and this one's a multiple of theta, then their difference is a multiple of theta, and so this one's a multiple of theta, which is contradiction. Oh, so I think we're done. Yeah, we are. We're done. Okay, that was that was very, very quick. That's how long a P1 should take. I think. Yeah, I feel like they could have swapped days 1 and 2 over, at least with how it's going now, because how it's meant to work is the day one is meant to be a little bit easier than day two. And we have here is like problem at least for me, problem four on day two is way easier than problem one on day one. Okay, so let's do. I don't even think the write up is that hard. Okay, so IMO 2026 problem four. So okay, so claim one. If theta divides 180, Mulan wins. Whoosh. Okay, so given arbitrary ABC, okay, okay, as again, but what if you have a triangle and then you need to pick? Yeah, what if you have something like this? What if you have a triangle? Oh, okay. What if you have a triangle and then something like this, and then let's say your theta is 30, and you have to pick a point here that's not right. Yeah. Okay, no, we can just make sure both of the bottom angles are multiples of theta. Fine. Okay. So yeah, let's do that. So given arbitrary ABC, as theta divides 180, um, we can select a point on BC so that angle uh, APB is k theta for some yeah for some integer k. Mm. Okay, but why is that true? Because okay, wait, if these wait, what are the factors of 180? Right. One, yes, factors of 180 are like one, two, wait, okay, wait, which of the factors of 180 aren't factors of 90? Because you can definitely get one with 90. So the only ones we care about, okay, so what 180 is 2 times 90, um, which is 2 times 2 times 45, which is 2 squared times 45, which is 2 squared times 3 squared times 5. So the only ones that aren't going to be factors of 90 are the ones which 4 divides. And the ones which 4 divides are 4, 4, yeah, because once we get a top angle of multiple of theta, we're clearly done. But we need to make sure we can draw the starting line. So 4 times 3, 4 times 5, 4 times 9. Okay, how many? They're gonna be three. There's gonna be six of these numbers. So 1, 2, 3, 4. One of them is gonna be 180. I mean, yeah, 180 doesn't count, so there's gonna be five. So there's one more, which is gonna be 4 times. Wait, what? Are these it? Four. Oh no, 4 times 3 times 5. Yeah. Okay. So this one, 4, 12, 20, 36. 4 times 15. 60. Yeah, 60. Okay, 60. Okay, so they're all factors of 60 except 36. Okay, you can definitely draw a line that gets you 60 because one angle in the triangle, one angle in the triangle has to be less than 60. And so if this one is if this one is say alpha, then I can draw an angle here that gives me angle 60 minus alpha, then I get 60 here. So I can definitely get one with 60. Oh yeah, and this argument works for any angle actually. So if you have a triangle, if you have any angle theta, either you have an angle equal to theta, or you have one angle less. If you're not guaranteed to have you're not guaranteed to have an angle less than theta. Yeah. Okay, so we just need to deal with 36. And for 36, okay, either you're going to have an angle bigger than 36. Okay, so for 36, we're fine with 36 and 180 minus 36, which is, so 36, 144. Yeah, I should probably should be a bit quicker with this bit. 180 minus 72, 108, okay. You can't have a triangle with all the angles bigger than 72. So you have to have one angle less than 72. And so you can definitely get one with 72. Fine. Yeah, that's fine. Okay. Yeah. Okay. So for some k and n, since either theta divides 90 or theta is 4, 12, what were those ones? 4, 12, 20, 36, 60. If theta divides 90, we take p as foot of the altitude. If theta is 4, 12, 20, or 60, there must be an angle in the triangle less than equal to 60. If equal to 60, we win. If less than 60, say angle C less than 60 log, we construct P by taking angle uh, PAC as 60 minus angle C, giving angle angle APB equals 60. If theta equals 36, one angle in the triangle must be less than 72, say angle C less than 72, we construct P. Yeah, this is probably quite a boring thing to watch. Yes, we construct P by taking P A C is 72 minus angle C, giving angle APB. Okay. So we so as theta divides 180, um theta divides 180 minus k theta. So we what's the name? Shan Yu. We force Shan Yu to pick a triangle with top angle of the form say theta of like let's do something like n theta for some here, and from here we just split n theta into theta and n minus 1 theta, forcing Shan Yu to pick the triangle with n minus 1 theta each time, which eventually forces an angle of theta. Yeah, I mean, like, clearly, like, and yeah, yeah. I don't think you don't need to justify that. Okay, claim two. Claim two. If theta doesn't divide 180, then can you can keep picking triangles where none of the three angles are of the form n theta for some instrument. Okay, so like Chan Yu starts with a triangle, right? Yeah. So Chan Yu picks a triangle with no angle a multiple with no angle of the form here, where of the form thing. Then as theta doesn't divide 180. Wait, let's just say what's that good angle? Good angle. This is like 180, APB, and APC can't both be good. The only way both triangles have a good angle is if log APB and GAC, which gives angle C is angle APB minus angle GAC is good, which is a contradiction. Okay, we're done. Yeah, nice. Wait, hold on. Hold on a minute. Um, oh, but like, what if, oh yeah, what if theta is like 180 over 7? We haven't covered that case. So, yeah, our first claim, we've only proved it when theta is because we use this divide thing. Yeah, but like, 180 over 7 would work. Okay, so we need to prove that, okay, we need to prove that if, okay, I think this might be the hard part of the question. I don't know. So we need to prove that if you have a triangle and an angle theta, you can always select the point P here. So the angle APB is k times theta for some integer k. And the only reason this wouldn't be true, so we're looking at angle APB. The only way this wouldn't be true is if you have like, you can say like k theta, and then k plus 1 theta is like somewhere. No, k plus 1 theta is bigger. So this one's going to be k minus 1 theta. And then k, k plus 1 theta. You see, so we consider like the R, the set of points. So the angle APB is k minus 1 theta. Yes, let's say k is the largest number, so that angle APKB is k theta and pk is to the right of c. Then we're saying for k plus 1, the arc intersects on the right of b. So we're going to have this angle is 180 minus k plus 1 theta. Is that surely that's not possible, right? 'Cause you have 180 minus k theta plus theta. So then angles in triangle APK plus 1 PK are going to add up to more than 180 because these two alone add up to 180 plus theta. Yeah, okay, I think this is a better way to prove it. Okay, so um yeah, so um yeah, this thing is wrong. So it's not either theta divides 90 or wait, I need to so if theta is 180 over k, where k is a positive integer. Yeah, so this bit is wrong. Yeah, so yeah, okay, so all this stuff, all this stuff is not correct. Okay, so we're gonna cross this out. Yeah, okay, and we're gonna put a little asterisk here, and we're gonna write it on here. Um, what are we doing again? We're showing we can select a point on BC so that APB is case only for some condition. Yeah, okay, because suppose otherwise, um, take K maximal, like consider, yeah, the circles passing through. Yeah. So arc AB not containing P subtends K theta. Arc AB, wait. arc AB subtends k theta for the arc on the opposite side. Yeah, opposite side of AB to C. Okay, I'm gonna say like yeah, let let this meet BC at PK and like K be maximal. So angle APB is K theta, well APK and PK is to the right of C. Then then PK plus one is to the left of B. So angle APK plus one B is 180 minus K plus one theta. But then looking at triangle APK plus one PK, we have the angle PK plus 1 plus the angle at PK is 180 plus theta, which is impossible. Okay, so um yeah, I think we're actually done now. Hopefully there's no other mistakes. Yeah, so we force Shan Yu to pick a triangle with its top angle of that form, yeah. And you can just split it. Yeah, and you're good. Yeah, I shouldn't say divides. I should say like if theta is not of that form. Yeah, hopefully this is fine. Yeah, yeah. I don't really want to try question 6 anymore. Yeah, I think let's check question 4 again because I think it's quite fiddly with the details. Okay, we've got like how long we've got like yeah we got like we got time. I think question 5 is 100% correct. Like question 4 is still feels a bit weird. Um, oh, okay, so I think we got a winning strategy. Let's check this one. So you have a triangle where no angles are multiples of theta. Well, not multiples, like an integer times theta. And then you can you put a point. So this one isn't a multiple of theta. This one isn't a multiple of theta, so this one can't be a multiple of theta either. And then this one isn't a multiple of theta, and you can pick a point So neither of these are multiples of theta. Yeah. Okay, so given this one isn't a multiple of theta, and this one isn't a multiple of theta, this one can't be a multiple of theta. And this one isn't a multiple of theta, and this one isn't a multiple of theta. So this one can't be a multiple of theta either. So the only one that, so yeah, so if this angle isn't a multiple of theta, this triangle has no multiples of theta. And so you can pick it. And one of these two have got to be not multiples of theta. So yeah, I think the strategy for Shan Yu is solid. I think I think this is solid. But like, yeah, I think yeah, this is solid. I think I think this bit is also solid, right? Like if we so yeah, k theta is 180. So you prove that you can pick a point here. So this is some multiple of theta. And then this one's going to be some multiple of theta as well, because it's 180 minus m theta, so it's k minus m theta, isn't it? Yeah. And then and then you get a top angle at multiple of theta, and then you win. Yeah. So this was the main thing we have to show, that we can select such a point P, and we showed it because of this thing. Wait, hold on, wait. Um, wait, this one's minus. Oh no, no, there's no way. There's no way. Oh, okay. So they add to 180 minus theta. Okay, so this one is going to be theta. Yeah, which means angle A is less than theta. But surely one of the angles have got to be more than theta, man. Oh yeah, fine. So yeah, so this thing forces one of the angles to be theta, to be less than theta. But you've got three angles, and because theta is 180 over k for an integer k. If k is bigger than 3, this is less than 60. If theta is 60 or less, you can't have all the angles in the triangle being less than theta, right? So, and like 90 we got. Okay, so 90 you just drop the height and you win. And then for any other theta, you can pick a point P, because one of the angles is gonna be more than theta. Yeah, okay. So the thing with arcs, it's not the angles add to more than 180, but it's that, which is not impossible, but which gives angle pk plus 1 a pk. It's theta, so theta is bigger than angle BAC, but for k bigger than equal to 3, theta is 180 over k, which is less than equal to 60. So at least one angle needs to be needs to be more than theta. 4 theta less than equal to 60, 4 theta equals 90. you win by dropping the perpendicular. Yeah, so I think I'd say this isn't a hard problem, but at least for me, filling in the details is quite hard. I think like similar to problem one, because watching down and back, the write up took me 30 minutes. So I said it took me 1.5 hours. It's more like it took me 1 hour and the write up was 30 minutes. And I think this one is kind of similar. So I think the key idea in both problems one and four, I think the key idea is not that hard to spot if you've been doing if you've been doing some practice. But I think the details are are not as easy as they can be.